So let's derive the dot product formula from the law of cosines. So the dot product formula is given vectors A and B with an angle theta between them, then the dot product of A with B is the magnitude of A times the magnitude of B times the cosine of the angle between them. So the way we will go about this is to first define a vector between A and B called C. And so C is going to be B minus A, right? So if you subtract two vectors, you get the vector going from the one you're subtracting to the one you're subtracting from. Or you could think about it as if you add A to C, tip to tail, then you get B. So we're going to go directly to the law of cosines, which says that C squared, the magnitude of the side C of this triangle that these three vectors form, is equal to the magnitude of A squared plus the magnitude of B squared minus 2AB cosine theta. So we know that the magnitude of C squared, well, that's the magnitude of B minus A squared. And, well, the magnitude squared is the same thing as a vector dotted with itself. Why? Well, because, as a side note, so we take a vector A, dot it with itself. Let's say A has three components, A1, A2, A3. Then the dot product is, let's call it the pairwise multiplication of two vectors. Well, that's just the sum of the squares of the components of the vector, which is the magnitude squared of the vector. Okay, so then this equals A squared plus B squared minus 2AB cosine theta. And we can break down this dot product because it's a bilinear form. So what that means is it's linear in both arguments, so in both of these parentheses. And what exactly that means is that we can distribute. So we have B dot B minus A dot B minus A equals the right hand side, and then we can distribute again. So the first part was linearity in the first argument, and now this is linearity in the second argument. And distributing the second dot product. So we have two minuses, so it's plus. And, well, B dot B, that's B squared, so we can cancel that from both sides. And A dot A, that's A squared, so we can cancel that from both sides. And we also know that the dot product is symmetric. So we can flip it and it's still the same thing. So we just have 2 of the dot product. And then just cancel the -2 from both sides, and we have our formula. So what this formula says is the classic description of the dot product is how parallel 2 vectors are. So we can think of that in 2 different ways. So one way we can think about that is by projecting the vector A onto B. So the component of A parallel to B is A cosine theta. So if we multiply that by B, we have B times the magnitude of A that's parallel to B. So it's their parallel magnitude, if you will. So B times A cosine theta. And that's just a regular product, because these are scalars. Or we could project B onto A. And it doesn't matter which way we go, because the projection of B onto A, the magnitude of that is B cosine theta. And so no matter which way we project it, the cosine theta tells us how parallel they are. So in this case we have A times how much of B is parallel to it. And that's all. Thanks for watching. Let me know what else you'd like to see. Make sure to like and subscribe, drop a comment, and check out my website, westworks47.com, for tutoring and applied math consulting. Thanks.